the average velocity. Average velocity. Consider the particle P having a position vector r1. Consider a particle P having a position vector r1. If the particle is moving from P to Q, in Q having the position vector r2, then the average velocity is given by delta r by delta t. This delta r value is equal to r2 minus r1. Delta r is equal to r2 minus r1. The average velocity is defined as a ratio of displacement vector to the time interval. Displacement vector to a given time interval. So this is a V average. This V is a vector quantity. This velocity is a vector quantity. This is average velocity. Average velocity means ratio of displacement to the time interval. And average speed. Average speed means total path length travelled by a particle. Total path length travelled by the particle in a given interval of time. This is the explanation of average speed. So average speed means total. Now we see motion along one dimension. What are the dimensions? X, Y, Z. These are the dimension. Here we see the average velocity in one dimension. Velocity means displacement by time. Velocity means displacement by time. Average velocity equal to delta x by delta t. Delta means difference. Difference means the difference between higher value to lower value. So delta x equal to x2 minus x1 and delta t is equal to t2 minus t1. This is average velocity in one dimension. If the particle is moving in one dimension, the average velocity is given by delta x by delta t. Delta x equal to x2 minus x1 and delta t equal to t2 minus t1. The instantaneous velocity. When the word instantaneous velocity is arise, we put the time interval value. Limit delta t tends to 0. Always the limit value starting from 0. Why we put this term only delta t? Because this delta t is varies. It is a independent value and delta x is a dependent value. So we put the time interval value delta t tends to 0. Delta t tends to 0. Delta t ஆனது மாறுது. இதை மாறுறதை பொறுத்து தான் டெல்டா எக்ஸ் மாறும். அதனால் நம்ம வந்து டெல்டா டீக்கு 0 அப்படிங்கிறது இந்த டேர்முக்கு மட்டும்தான் லிமிட் வேல்யூ போடணும், கீழே உள்ள இந்த டேர்முக்கு. This delta x by delta t is always written as dx by dt. This delta x by delta t is always written as dx by dt. Delta means difference. So dx delta t equal to dt. This is equal to velocity. So v equal to dx by dt. Now we cross multiple this v dt. So dx equal to v dt. We want to find the x value. Suppose we want to find x. We integral this term. So integral x1 to x2 dx equal to integral t1 to t2 v dt. This full term means the area under the graph. This dx is explained as displacement. So in this graph, in one dimension we always see in positive and negative directions only. This is velocity, this is time. So this graph is gone as shown in figure. The area under the curve will give the displacement. The area under the curve will give the displacement travelled by the particle from time interval t1 to t2. Time interval t1 to t2, this graph represents the area under the curve will give the displacement. Suppose the particle moves in positive direction and negative direction. This graph explains this is a positive displacement and this is a negative displacement. In the previous class, the integration class, we see the integral value. Suppose we draw this curve and this is the area under the curve. The area, how to calculate? We get area, the difference between these two terms and this peak and this peak. This area will give, this is B and this is A. So B minus A and into C. This is the area value. So like this, in the velocity time graph will give the displacement. Velocity time graph will give the displacement. Velocity equal to displacement by time. Velocity equal to displacement by time. But we want dx, so we cross multiply this v dt. So area under the curve will give the displacement. Area under the curve v and time interval t gives the displacement. This is positive and negative displacement curve, positive displacement and negative displacement. And now we continue relative velocity in 1 and 2 dimension motion. If the two objects A and B moving with a different velocity, this velocity of A with respect to B is given by VAB. So VAB is the relative velocity of A with respect to B, and VBA is the relative velocity of B with respect to A. So VAB can be written as VA minus VB, and VBA can be written as VB minus VA. In this relative velocity cases, we go 3 cases. First case, VA and VB are along in opposite directions, but in same tracks, but in opposite direction. So we change only negative sign only. First we put negative, and the direction is always in the case true opposite. So we also put another minus sign. So minus minus plus. So VAB equal to VA plus VB, and VBA equal to minus of VA plus VB. This is case 2. And in case 3 value, case 3, VA and VB with angle theta. If VA moves with an angle theta with VB, VAB equal to VA minus VB, and the result and the magnitude of the VAB value is given by VAB equal to root of VA square plus VB square minus 2 VA VB cos theta. Tan beta is the angle between these two vectors A and B. So tan beta equal to VB sin theta by VA minus VB cos theta. In the third case, theta values we give 3 steps. First is the theta equal to 0, and next theta equal to 180 degree, and theta equal to 90 degree. If theta equal to 0, what is the value of cos 0? If theta equal to 0, in the third case we see this in 3 ways. If theta equal to 0, we put VAB. In this term VAB cos 0 equal to 1. So root of VA squared plus VB squared. This cos value is 1 minus 2 VA VB. This makes A minus B the whole squared. So VA minus VB the whole squared. So we take out from the root value VA minus VB. This is VAB. If the value theta equal to 180 degree, cos 180 degree is minus 1. Cos 180 degree is minus 1. If it is minus 1, minus minus plus, then it is A plus B the whole square. So this VAB is VA plus VB, or VAB is VA plus VB, and VBA is VB plus VA. If the theta is 90 degree, cos 90 degree is 0. So the last term will be cancelled. So VAB equal to root of VA squared plus VB squared. VAB equal to root of VA squared plus VB squared. In the last term, theta equal to 90 degree, VAB equal to root of VA squared plus VB squared. Because the last term is 0, so it is neglected. So remaining these two factors, we return the VAB values. VAB equal to root of VA squared plus VB squared. Consider this figure. The man goes in the velocity of Vm, and the rain falls with the velocity Vr. So this is like the third case. make an angle theta. So the resultant of the values will be given like this: VAB equal to VA vector minus VB vector, VA vector minus VB vector, because it is like third case theta value VA minus VB vector, and we find the magnitude values VAB. This VA and VB is VM and VR. So VAB can be written as, VAB is written as VM minus VR. VR minus VM. So this VAB is a third case like this. So VA is always equal to VR, and VB is equal to VM, and theta value, theta equal to tan inverse VM by VR, tan inverse VM by VR. This theta is 90 degree, sin 90 degree is 1. So VB equal to VM, and VA minus VB cos 90 degree 0. So this term will be cancelled, and so the theta value is equal to tan inverse of VM by VR. Next class we see next.